So let's continue with another example. So instead of continue what we just did, I would like to create yet another version of main function to test something else. But I also advise you, once you're done with your debugging session, and you see I still have this breakpoint. In fact, you can go to debug, Windows, and breakpoints, and you can display the list of all breakpoints. You can have more than one, but I normally delete them once I'm done with them, right? Because it's just something that I don't expect to get in the way when the next time I want to debug something. I don't want my old debug breakpoints to just simply to hang around. I get rid of them, right? And also, once you place the breakpoint by simply clicking on the margin, for instance, you can click again to get rid of it. For instance, if you click this accidentally and you want to just get rid of it. But generally speaking, remove breakpoints once you don't use them. Just you don't need them. So moving on. Let's try, let's copy and paste our main function one more time, right? One more time. Copy, and this one will be renamed again so that it doesn't get in the way, in the way, and we just try another main function. This time I will just reduce it to blank code like this with just a single return statement, right? And here I continue to, like I told you, starting with chapter 5, most of the time the samples from the book will have this look and feel like main, try something, and then catch, and it's a runtime error, and print what, and then print program failed. Okay, so let's do this. Let's create integer x equals 10. And let's create integer y equals 2. And let's say stdcout maybe we can print x divided by y equals just say x divided by y. Right, we'll display the value, new line, and simply exit. Right. To demonstrate, so this is all hard coded. 10 divided by 2, right? So I build this. And it gives me a warning that yeah, so I will return one over here. Okay, there was a little technicality that it wanted to return 1. Yeah, so back to our demonstration, we have this function main. And currently I was able to build it and run. And of course it says 10 divided by 2 equals 5. Right, so this is my output that I'm generating. Very good. That's the output. Everything works as expected. Now let's change y to 0. So very likely 10 divided by 0 is an illegal operation. Division by 0 is not supported by the CPU. The CPU is programmed to interrupt execution of the program and basically report the offense to the operating system. So let's see how this behaves. Okay, so build with the now y equal to 0 and press F5 to run it. Right? So it says unhandled exception in week 5 exe integer division by 0. This exception code is actually defined by the CPU, not by C++, not by the operating system. It's the CPU that generates the specific unique code and says, look, this is the condition that we're currently experiencing. It's the CPU that stops execution of this program and reports this to the operating system, right? So this was one behavior. The second behavior would be for me to say press Control F5. So this I was actually running it in debug mode. Control F5. Run this program by actually wait a minute. Debug. First of all, I need to stop debugging and restart it. But this time not in debug mode. Just simply run the program as normal, not in debug mode. You can see that simply this is the entire output that I get, and I will show you. And I will show you that this is my output, right? The program runs without help of debugger, and this is what happens. It says 10 divided by 0 equals, right? And then we're trying to make an attempt to divide by 0, which of course, like I told you, is interrupted by the CPU. And in debug mode, it was saying exception such and such. In our case, program exited with code this, and it's very likely that very exception. In fact, we can probably find out, right? If we start the calculator, I'm just doing it on the side, right? And I switch to decimal input, and I enter it, and then I switch to hexadecimal. That's exactly it, right? Control C. This is this negative thing. If you control it to a hexadecimal, is like this value, which is negative value, right? And so this exactly the same exception code. If we Google it, right, this value should be very well known to Google. If we Google it, it should tell us that this is an exception, right? It would be interesting to Google it. Let's just do it very quickly to find out what the Google says about it. Again, this is not captured by a recording session, but simply doing the search exception code error Windows. So it's basically it says somewhere yeah, it's unhandled exception, trying to find a good source of information. Exception integer division by 0, right? So basically, if you Google it, it doesn't matter. Resources on Google essentially describe it as integer division by 0. You may be wondering why I bring this up. You may be under impression that if we said try and catch, then we're covered 100%. And this thing shows you that we are not. Hardware problems and generically speaking, division by zero is a hardware problem. We're asking hardware to do something that is not capable of doing. The hardware is designed to say, we will refuse this and simply stop doing what we're doing and notify the operating system. An operating system then converts this to this exception code and reports the exception. But, right, the important thing is that we never ended up over here. We never caught any runtime exceptions. So this try and catch is not 100% proven. You need to know which situations are not covered, and as far as I know, division by zero is a good example, right? So this division by zero cannot be combat by any kind of exception mechanism in C++. The only choice here is to say if y is 0, then you cannot do something like this. So realize this, right? My point is this try and catch is helpless against division by 0. It never caught it. It never reported anything about it. Our program crashed by attempt, to divide by 0. Very important. Very important, right? So the only way, like I said, the only way to combat it for you is to say if, right? If y is 0 proactively, right? Or we can make an assert or something, right? But here we need to do something about it ourselves. Try and catch mechanism is helpless. It cannot fight this really bad attempt to divide by 0. Cannot do it.